All right, final week of the lectures. So far, we learned about the procedural and object-oriented aspects of the Java programming language. And the final bit of the course is for you to explore the Java library classes and methods that have been built by other Java developers and use them in your own application. So the very spirit for this lecture is for you to learn how you can stand on the shoulders of giants who are Java developers contributing to the Java library classes and methods. As usual, let's take a look at the learning outcomes to see what we want to achieve before we dive into the details. Number one, we want you to know how you can explore by yourself the Java API, standing for Application Programming Interface. So we'll look at 3 case studies of the 3 classes. And also we'll review the concept about method headers and parameters versus arguments. So these will be important terminology when we actually talk about using Java API methods. And we'll talk about 2 categories of library methods you can use. So the first one is about static methods. So these are essentially the utility methods you have been building. And so the class we'll use is the math library. So the math library class is a very special class where all the methods are simply just static, meaning that you can simply just call the methods using their class name without creating any context objects. On the other hand, the other 2 classes we want to introduce come from the so-called collection library category. So namely array list and also hash table. So all the methods there are simply non-static, meaning that you must create instances of those classes as context objects and invoke the methods accordingly. So that's kind of the difference between static versus non-static methods. So that's something we'll review as well. All right, let's now speak about why you will want to use API rather than just building everything from scratch, which is pretty much what you have been doing up to now for the course. So each time before you start solving a problem, as a beginner, it will be very crucial to implement everything by yourself. So this is why so far we really emphasize about the requirements where you simply just cannot use any Java library classes or methods, because you really don't want to compromise your learning opportunities of building those kind of basic control stuff. Rather than just reusing something that has been built by somebody else. You really want to learn how to build those constructs by yourself. However, once you become more experienced, you will want to check to see if this problem you want to solve is already solved by one of the Java library classes or methods. In that case, if your labs or your tests actually got no constraint on using any library classes, then yes, you can definitely feel free to do it. However, I would suggest you still really want to train yourself by building everything as much as possible by yourself. But sometimes for the routine tasks, you can definitely use the library classes or methods. So you want to draw the balance on your own. All right, so what's the rule of the thumb? So you do not really want to reinvent the wheel. So it's a good saying over here, all right? Whenever there's something routine that has been done already, why don't you just reuse it, right? If you're permitted to do so. So an application programming interface or API as an acronym is simply a collection of programming facilities like classes and methods for reuse. So those solutions have been built already, they're correct, and they're simply there for you to reuse them without worrying about if they're correct or not. You can assume they're simply just correct. So you can reuse them for building your applications. And then so Java API simply contains a library of classes. For example, the 3 we're going to look at will be math, array list, and also not hash map but hash table. Hash map is just another class, but we'll look at hash table for this lecture. And also different methods like a square root for the math class, add and also remove from the collection library classes. And this is the link to the Java API. Let me show you briefly the website over here. So let me just show it to you over here. So if you simply just go to that link, you can see these are all the classes that have been hyperlinked for you to actually explore. Okay, for example, if I simply look for the math class, so the math class will be one of the classes we're going to look at, and also array list. Right, that's just another one. If you click on the link, it's going to bring you to the page for that particular class with all the methods supported. Okay, and notice one thing here: for all the API classes, and methods, you don't see how exactly they implement the methods. You don't see them. For you as a user, you simply just call the methods by reusing the block of code that has been built, like a black box. Okay. Right. So that's a page you can definitely explore, but I'll show you some fragment of the important information in order for us to illustrate the examples. We'll do that later in the lecture. Okay. All right. To use a library or class, you have to put the corresponding import statements from that for that particular class. For example, if I want to use the array list class over here, I want to say import, and then the array list actually comes from the Java utility util package. So I'm going to say import java.util.array list. If I want to if I simply want to use all the classes from the util package, I can simply say dot star. So you have seen this syntax actually in your programming tests already. All right, and then so after you have imported the library class, you can now declare your own class and then declare your attributes mylist of a reference type. So that will be array list over here. So we'll talk more about how you can declare collection classes in a moment. Okay. Right, so let's now review some concept very quickly. Let's go over the concept about classes versus methods. Okay. A method is really a named block of code reusable by its name, right? That's something we emphasized already when we spoke about the object-oriented aspects for Java programming language. So for example, if you actually want to use the square root method from the math library class, right? You don't really have to know how exactly the square root method has been implemented. You simply just call its name and then use it. Okay, that's all you gotta do. So the implementation of the code for the square root for the method is simply hidden from you. It's a named block of code, and this block here is like a black box. It's simply not visible to you. You just use it without knowing exactly how it is implemented. And you only need to know how to call that. So when I say how to call, so depending on whether the method you're calling is a mutator or accessor, you may want to call them in a different way, right? For example, if you're using mutator method, you can the call can just stand alone. But if you're calling an accessor method, then you want to do something with the return value. So that's what I meant by how to use it. Right? We'll see examples later. A non-static method. So now we talk about the distinction between non-static versus static. Okay, let's now go over the some example on the slides, and now I will illustrate a little bit more on the iPad. So the non-static method must be called on using a context object for non-static method. Okay, so this is simply just some example over here about using array list over here. So here, it would be illegal for you to simply use the class name array list and then say dot add, because the add method from the array list class is actually non-static, meaning that if you want to call the non-static method add, you must create some context objects of type array list, and then you can use this context object list to call this particular method here. Okay, that's something we'll see a little bit more about how you can use the array list class. Okay, but just very recap for this particular bullet points. Whenever you're calling some method which is non-static, so that means you have to the left of the dot, it must be some context objects rather than a class name. But when can you actually use a class name to call a method? Well, when the method was declared to be static. So that's another category over here. So the static method can be called using the name of its class, right? That's a very well-defined distinction you have to make. So for example, here for the math class, it's so-called utility class, meaning that every method in the math class is actually declared as static, meaning that for calling the square root, I really don't need to create a math class objects. I can simply just use a math class name over here to the left of the dot. Okay, and then by calling that, I'm essentially reusing a block of code hidden from myself, and then it will be executed and calculate the square root, well, something like that, right? All right, so now let me just illustrate a little bit further about the distinction between non-static and also static quickly. Okay, so it will be very important for you to actually always remember this distinction over here. Otherwise, you can easily run into compilation error. Okay, let's say we have the same class over here. Let's say we have class over here, and let's say let me just say A over here. So the name is not really important. I'll just say A. And let's say you might have some private attributes. Let me ignore them. And then let me have two methods over here. Let's say I got maybe public. Let's say static, like a utility method. let's say returning an integer, and then I would say maybe method 1, I would say m1. That one there simply takes integer I and also string s over here, and then the implementation for the method I'm just omitting it. Okay, let's declare another method. Let's say that is non-static, so I can say public, and then no static keyword over here. I'll say, let's say also returning integer, and then m2. Let's say string s and also integer I. I'm also omitting the implementation detail over here. And just a little bit aside, remember when we spoke about when you're actually using a static method, but somehow you're referring to some non-static attributes inside, you will get the well-known error about referring to a non-static variable in a static context. So that's something you want to review yourself from the previous lecture. All right. Okay, so now let's speak about exactly how you can use these two methods. Okay, let me just box them over here. So this is about how you can declare this particular class. Okay, let me say we have another box over here. So this is just another class where I'm trying to test the class. Okay, you can think about this is the tester. It can be either console applications inside the main method, or it could be maybe some JUnit tests with assertions. It can be either way. Okay, so let's say this. How can I actually use the let's say not the static method over here? How can I use it? In order for me to use it, I just don't need any context objects. I can simply say a dot and 1. And then I want to make sure all the argument value I pass should really be compatible with the declared parameter types over here. So you should be integer followed by string. So for example, it can be 23 followed by maybe Alan. Okay, so this will be 1, and this will be one way. Of course, it's actually some accessor, so I would expect maybe I should also maybe assign the value over here to be something. So I can say maybe integer j is assigned to this particular method return value, right? Okay, hopefully that makes sense to you. How do we use, let's say, this particular method here, which is non-static? You don't see any static keyword over here. You don't see any static modifier here. So what I should do is I should really first create a context object of the compatible type, which should be of type A over here. So I would say maybe A, and then objects is assigned to new. Let's assume we simply have the default constructor. So now it will be A over here. And then how can I call that? I can say integer, maybe K is assigned to, I can say objects dot, so the context objects, and I can now call M2. And then it's going to take maybe maybe Tom. And then another integer will be 46. All right, so it's a very quick syntactical reminder about how you can use the static method, in which case you can simply call that using the class name. Okay, and then for the non-static method over here, you can you have to create some context object in order to call them. Right? You might have a question like this: can we actually call the static method with a context object, for example, obj? For example, can I do that? It would be okay to do that. However, you will get some warning from Eclipse Java compiler, so it's not really recommended. It's pretty much like when we spoke about before. When you try to get access to the static counter by using some maybe context objects, it will be okay, but conceptually it's confusing because that means you're not really understanding about how to use static variable. You should always use just a class name to actually call the static variable or the static method. You want to avoid even warnings. All right, so that's about the distinction between static versus non-static. Okay, quick review. And what about a class? A class is simply going to be a collection of related methods put them to be put together. All right, so for example, the math class actually supports all the methods related to the more advanced mathematical computations. So they claim that any mathematical operation that are actually specified in your high school math textbook, you will be able to find how to compute them by using some of the methods in the math class. I'll let you explore that. We'll see only some common ones in the lecture, just some, not really all of them. All right, let's now review quickly about parameters versus arguments, right? Let me again speak about the slides, and then I'll use the example I just built on the iPad to explore further. So parameters are simply just the input variables that you actually declare for your method, okay? And it's really important because every time when you actually read the API page for a particular library class, let's say array list, so all they show to you will be the method parameters. So that's something I will use the term without explaining any further. So please make sure you actually review the concept about parameters. For example, you can see this apparently it's a declaration for some method, let's say pow for power. So it's going to be a to the power of b. And here a and b are set to be the names of the parameters. And double is set to be the type of the first parameter a. And double here is set to be the type of the second parameter b, right? And so the two parameters, and also we got return type double over here. And when you combine all these information together, they are called the header of the method, which we'll review as well in the next slides. What about arguments? You can think about you only declare and declare your method only once in the corresponding class. However, you may have as many users as there might be. They will actually call this particular method by invoking its name. So whenever they call this method here, they have to pass so-called argument values to really to be compatible with the first parameter. The first argument should be compatible with the type of the first parameter, which is double. And the second argument value should be any value that will be compatible with the type of the second parameter, right? So the distinction between parameters versus arguments, we also spoke about them when we spoke about OO in the previous lecture. You can also review that. All right, so it's going to be the input values. You can see it's really values versus variables, right? That's also try to pay attention to the wordings I'm using in the slides. All right, so how, for example, you can see here 3.4 is really the argument that's compatible with the first parameter. And also 5 is also the second argument that's compatible with the type for the second parameter over here, right? Straightforward. And argument values must conform to the corresponding parameter types. For example, here, you can see if I say math the pow over here. Oh, by the way, pow is actually a static method in the math class. That's why I can simply use this, the class name, without the context objects. And you can see this is a string, which is not compatible with the double. It's quite easy, right? Let me just make the notes quickly, and then we are done with the review. So now, in this particular case, can you identify parameters versus arguments, right? It's actually quite important. So here you can see here, let's say integer I, string s, and also integer I. So these are the parameters. So these are the parameters. Right? So these are the inputs for individual methods. So what about arguments? So let me highlight in another color. So you can see here 23, and also string literal Alan, and also Tom, and also 46. So these are the arguments. Right? It's really important for you to get the terminology right. So these are simply the arguments, right? Okay, so that's about the review I'd like to show to you. Let's go back to the slides. And a final slide for review before we look at the 3 case studies. So what's really the header of a method? The header of a method informs the user about the intended usage, right? Let's see. So it should be the name of the method. You should really know what's the name of the black box you should really call to reuse its block of code that's hidden from you. And also the list of inputs about parameters. So when you use them, you will know what kind of argument value you can pass that's compatible with the parameter types. Right? You can see parameter. You can see the parameters, the names, and also the types. Right? And also the type of the output. So the return type as well. So now, so how do we distinguish between accessor versus mutator? That's also something we said about, right? When we talk about OO. So the method with the void return type are mutators, which means the method call can stand alone. It cannot be used as an expression value for maybe printing, or maybe for variable assignments, or maybe for comparing against some value in the assertion, right? And also, on the other hand, if the return types is actually non-void, it can be primitive type or it can be reference type. In that case, they will be accessors. And typically, if you're calling an accessor, you should really try to make use of its return value for printing, for comparison, or maybe for variable assignments, right? All right, in Java API, the method summary section, which we'll show to you for each of the 3 classes we're going to look at for case studies. The method summary section lists the headers and description of the methods. That's something we'll look at as we go into the case studies. All right, so up to now, it's just a very quick discussion about why we really want to use API. Just remember, at this point, you're still the first year, even though you're moving quickly very soon to the second year. But I would say you're still considered as the beginner of for programming. So you definitely want to build from scratch as much as you can, especially when you're asked to do so. But there might be some scenarios, especially maybe for your side projects, if there's any routine tasks that you actually want to do, but it may have been solved already by some Java library classes. In that case, you can feel free to actually use them for your side project purpose. And just review all the terminology about parameters versus arguments, and also static versus non-static methods, and also header of the method before you move on to the next part of the lecture.